Thank you, Mariana. Hi everyone, I'm Esin Ergen from Istanbul Technical University, and today I will present my student's work, Ceyhun-Özoğul's study. Unfortunately, he couldn't be with us today, and I will try to explain what he did in his studies. So the topic is metadata extraction of RFIs using natural language processing and machine learning algorithms. So let's start off with definition of RFI. What is an RFI? It's a request for information, and it's an official document that is created by the contractors to ask for additional information or for clarification related to issues in design, construction, or related to other documents. As you can see on the right-hand side, there's a rather simple RFI that describes a problem related to an electrical component. And the contractors, designers, or construction managers in their database, they have a wealth of information hidden in these RFIs, but because they describe the problem, they discuss the solutions and end up with one solution. But since this is an unstructured document, it's really hard to extract the lessons learned out of these documents. So what you can do is you can use metadata when you are analyzing the RFI documents. But we see that the users who are creating these RFIs are reluctant to fill out those fields in their systems. For example, this is a system where you enter the metadata and then create the RFI. The examples of metadata are subject, distribution code, facility code, or discipline code. And the users, if they can, they try to skip these fields and leave it blank. Or if it's not an optional field, if it's a mandatory field to fill out, then sometimes they make mistakes and they enter this metadata incorrectly. So the users are reluctant to fill out this section because it requires additional time and effort. And in the end, we have a low data quality, and this affects the efficiency of RFI analysis and efficiency of the project management. So this showed us that there is a need for automatic extraction of metadata for RFI documents. And first, we looked at the literature. And metadata extraction is basically a classification problem. And in the literature, RFI documents were classified before, but these were done manually. And in those studies, they classified the RFIs based on the discipline, type, and causes. The studies on automatic classification in the construction management domain focused on other different areas. For example, some studies focused on accident analysis, and they looked into the accident reports and classified those reports based on the accident types. There are some studies in contract management. They determine the vagueness of the contractual clauses or other types of classification. Some studies looked into building information modeling related documents and cases. For example, one of them identified the BIM users in BIM cases. And in facility management, you can find various studies where they looked into work orders and they determined the defect failure, cost failure, or they assigned the teams. The staff assignment was done based on the work order content. So to the best of our knowledge, the RFI metadata or classification was not done in the literature. So our goal was to analyze the RFI documents with NLP and machine learning algorithms to automatically determine the discipline of the RFI. To achieve this aim, we got RFI documents from a large-scale airport project. First, we started with 100 RFIs, and then we extended the research, and we looked into 2,333 RFI documents. And I will present the results for these for both of these cases. Our methodology includes NLP and machine learning. So we first started with NLP. We retrieved these RFI documents, and then we did labeling. So for each document, we determined the discipline, and we did tokenization, where we divided the sentences into words, and then we removed the punctuation marks, and we removed the stop words, which are given here. So in the end, we ended up with the major words that are going to be used for metadata extraction, and in that part we did vectorization and finished the NLP part, where you determine the frequency of the words. And by using this data, we trained two algorithms. One is KNN, and the other one is naive Bayes, and we used 80% of the data to train the algorithm and 20% of the data to test it. And we used cross-validation method, and in the end, we determined the performance by calculating the precision, recall, and F1 score. So for the KNN algorithm, we tried different K values, 3, 5, 7, and 9, and 5 gave the best result, so we used this value to compare the results with the naive Bayes, and with 100 RFI documents, naive Bayes performed better than the KNN method. Precision was 85%, recall was 82%, and F1 score was 82%. And for KNN, it was much lower. It changed between 60% to 75%. And then we increased the number of documents, and for about 2,000 RFI documents, the performance was increased for both algorithms as expected, and we had 98% precision, recall, and F1 score for the naive Bayes algorithm. So the results showed that naive Bayes showed a better performance, and this finding is similar to the findings of studies that were conducted in contract management. By using this method, you can automatically extract the discipline of RFI documents so that these documents can be created in a shorter amount of time, and we can reduce the number of incorrect entries, and we can do more precise analysis. The future work includes diversification of algorithms, so we will try, actually we are working on extending the algorithms, and we also plan to work with other types of metadata. Thank you.
Thank you very much, Esin. Any questions from the